Let's dive right into this explainer and look at a massive structural paradigm shift happening in software engineering right now. We're witnessing a fundamental move away from static, easily outdated search indexes, which, let's face it, have been the standard for years, and towards something incredibly dynamic that actually behaves the way a human engineer would. If you've been working with AI coding tools, you know the pain of an AI that simply doesn't understand the current, live state of your project. Well, that is all changing today.
Here's a quick roadmap of what we'll be covering. We're going to look at the limits of traditional RAG, introduce agentic search, and then break down exactly how the harness, context files, and precision navigation completely upgrade your developer workflow. Let's get right into it. Part 1, the limits of RAG. We've got to start with a frustration that literally everyone working in a massive monorepo knows all too well. I mean, have you ever asked your AI coding assistant a question, and it confidently points you to a module you deleted last sprint or a function you renamed like 2 weeks ago? Maybe you've watched it just boldly hallucinate an entire import path. Yeah, it's the worst. When you're dealing with millions of lines of code or thousands of active developers, scale becomes the ultimate stress test. Traditional AI tools often fail here. Not because the AI isn't smart enough, but because the infrastructure feeding it information simply cannot keep up with the sheer velocity of your team's commits. See, traditional RAG, retrieval augmented generation, relies on embedding your entire codebase into a vector database to build a searchable index. The catch? Generating those embeddings takes massive compute and a whole lot of time. By the time you actually query that index, your team might have already pushed 50 new commits. It's high maintenance and inherently stale. Agentic search, on the other hand, completely flips the script. There is zero centralized index to maintain, none. It works directly on your real-time, live codebase, traversing the file system locally just like you do. Which brings us to part 2, enter agentic search. Let's look at how this new paradigm actually eliminates those stale bottlenecks. Think of agentic search like having a really fast junior engineer sitting right next to you, natively navigating your live file system. Instead of pulling from some dusty, pre-computed database, tools like Claude Code use the exact same developer utilities you do. They're using grep, parsing ASTs, reading files directly, and following references on your local machine in real time. This guarantees the AI is always operating on the exact same codebase state that you are. Yes, including those messy, uncommitted local changes you're working on right now. Part 3, the harness determines performance. Because an agent is really only as good as the environment you put it in. There's this huge misconception out there that raw model benchmarks are everything. People obsess over the baseline reasoning power of the newest LLM. But out in the real enterprise world, the ecosystem you build around the model is your actual secret weapon. If you just drop a genius-level AI into a massive, completely undocumented codebase, it is going to rapidly burn through its context window trying to figure out where to look. The tools and context you surround the model with, what we call the harness, dictates its success far more than the model alone. So what exactly makes up this harness? First up, we've got claude.md files. These are your foundational context, basically the rulebooks. Next, you have hooks. These are automated scripts that do things like run a quick linter or grab test coverage right before the AI answers, just to keep its output validated. Then we have skills. Think of these as on-demand expertise. Doing a security audit, load the security skill. You really don't want to bloat every daily session with rules you don't currently need. And finally, plugins, which let you bundle all these setups to easily share best practices across your entire engineering work. Part 4, layering context with Claude.md. Let's unpack that foundational layer and how we feed the model just the right amount of information. The real magic here is how context is loaded additively. It's brilliantly designed to absolutely prevent information overload. When the agent fires up in a specific subdirectory, it first grabs the local, hyper-specific conventions unique to that microservice. Then, as it explores, it literally walks up your directory tree. It eventually hits the root file, which should strictly contain high-level pointers and your biggest gotchas. By starting hyperlocal and expanding to the macro rules only when necessary, the agent stays totally focused on the exact scope of the task. Oh, and here is a massive real-world efficiency tip. Aggressively use .ignore files. You do not want your AI burning its precious context window, reading minified third-party junk, or build artifacts. And when you version control these exclusion rules, you aren't just saving the AI's memory. You are applying an instant, permanent noise reduction filter for every single developer on your team. The second they pull the repo, the AI already knows exactly what to ignore. Moving to Part 5, Precision Navigation via LSP. Context is great,
but navigating complex, typed languages requires serious pinpoint accuracy.
Look, doing a basic text search in a massive, multi-language codebase is a nightmare. Imagine grepping for a super common function name, like initialize. You'll get thousands of irrelevant hits, and the AI will waste all its time and memory sifting through them. That's why LSP, the Language Server Protocol, is a total game changer. It gives the agent the exact same symbol-level navigation a developer gets in a modern IDE. It knows the difference between identically named functions and can trace an exact reference across dozens of files instantly, with perfect language-aware accuracy.
Finally, part 6, upgrading the developer workflow. Let's tie this all back to how your engineering team actually manages this rollout day to day. To actually move the needle on developer efficiency, you have to actively manage this setup. First, strictly scope your test commands to the subdirectory level. If the AI triggers an entire monorepos test suite for one minor file change, you're going to get frustrating timeouts and wasted ton of compute. Second, you absolutely need a directly responsible individual, a DRI, to manage this AI ecosystem and keep the harness clean. Third, take your best setups, package them as plugins, and distribute them so it's not just tribal knowledge. And crucially, review your configuration every 3 to 6 months. These underlying models are evolving fast. Which brings us to a really critical question to leave you with. As these models inevitably get smarter, is your code-based harness going to empower them or hold them back? The entire future of human-AI collaboration and software engineering hinges on the ecosystem you are building right now. An overly strict rule written to fix a quirk in today's model might totally hamstring tomorrow's more capable update. Agentic search is completely rewriting how we interact with huge codebases, but its success relies entirely on the structure, context, and tooling you provide it. Build your harness thoughtfully, empower your agents, and watch your developer productivity absolutely take off.